Project Jigsaw, and basic module concepts. In this section, we will deep dive to introduce the Java Platform Module System, JBMS for short, in more details. It is Java 9's most important new core feature, the modularity, the result of Project Jigsaw, which will help developers at all levels to be more productive as they build, maintain, and evolve software systems, especially very large and scaled down systems. In that favor of JDK9 modularity, college students in upper-level programming courses will want to master modularity concepts. For career path preparation, as it becomes a very popular concept in software engineering nowadays. For now, if you need to understand the basics of Java SE 9 features and why it is here, I encourage you to consult the Common Overview Section 1, Why Java SE 9. Now, let's move on to see what we have to cover during this section. In this section, we are going to take a look at the Java Platform Module System, JBMS for short. Introducing the JBMS concepts, problem of the current system, Project Jigsaw history, and goals to solve non-reliable configuration and weak encapsulation pains we had in the previous Java releases. Explore module development in Java, how JDK9 is different from other releases, listing the JDK9 modules, what is the mother base module, how Java SE9 application is different, then list all the modularity related JIPs and GSRs for more information. In the module declarations, we will learn how to declare a module and explain all the keywords and directives related to the module declaration. Importantly, developing a Hello World application in a modular way, then how to compile, run, package such a modular application. And finally, how to develop and use a custom modules, then package them into modular jars. So, are you ready? Yes, let's start. Now, we move on to the first video of this section, Introduction to this module system. In this video, we are going to take a look at what is the module system, why we need it, and its long history. Explore the current system problems, then how the module system solves these problems, and finally highlights the difference between previous JDK's structure and the new JDK9 structure. As we know, Java SE 8 comes with 3 big new features, plus few more new features and enhancement. It brings functional programming to the language by introducing lambda expression, introduced Stream API to work with bulk data and streams of data in a big data way, and the new date and time API. This is one of the great features introduced in JDK 8. Also, it introduces static modularity concepts by providing 3 compact profiles, compact profile 1, 2, and 3, to be used as a modular system for scaled down systems. In the same way, Java SE 9 came with more bigger features, plus more new features and enhancement. The Java Platform Module System, which is the project Jigsaw, this is the main project of this release. Also, it brings Java Shell, introducing Rebel to the language. And finally, Mailing Project Coin, which contain some changes to the compiler and the language, and we will learn about this in Volume 3. Jigsaw project introduces a completely new concept of Java SE 9 Java Platform Module System. So, now let's have a look at the project Jigsaw history. The Java system, or Java SE platform, has been around since 1995. There are now approximately 10 million developers using it to build everything from small applications for resource-constrained devices like those in the Internet of Things, IoT, and other embedded devices to large-scale business-critical and mission-critical systems. There are a massive amount of legacy code out there, but until now, the Java platform has primarily been a monolithic, one-size-fits-all solutions. Over the years, there have been various efforts geared to modularizing Java, but none is widely used. Modularizing Java SE platform has been challenging to implement, and the efforts have been taken many years before. JSR 277 module system was originally proposed in 2005 for Java 7. This JSR was later superseded by JSR 376, the Java Platform Module System targeted for Java 8. The Java SE platform is now modularized in JDK 9, which is released last September 2017 to be at your hand, with a promise from JDK engineers to continue improving and enhancing the module system in the future releases. Now, let's address the current system problems to understand why all these efforts are made to bring modularity to the platform. Let's discuss why we need Java SE 9 module system. From different perspectives, the question here could be, what is the problem of the current system? Java SE 8 or earlier system have the following problems in the developing or delivering Java-based applications. As JDK is too big, it's better to scale down to small devices. 3 types of compact profiles to solve this problem has been introduced in Java SE 8. Compact profile 1, 2, and 3, but it does not solve this problem as they are static and not customizable. Also, the jars files like rt.jar and other jars are too big. It's very hard to be used in small devices. As JDK is too big, our applications or devices are not able to support better performance. It is also hard to test and maintain our applications and code base. And finally, the application is too big. There is no strong encapsulation in the current Java systems because public access modifier is too open. Everyone can access it. As public is too open, there is no restriction on accessing some of internal critical APIs, like all the packages under sun.asterisk or all the packages *internal.asterisk and the others. As the user can access the internal APIs too, security is also a big issue. It's a bit tough to support less coupling between component and provide service providers and service consumer for our applications. So the question here is how to solve such problems. To solve all these problems effectively, the answer is the Java Platform Module System, which is here and already shipped with Java SE 9 release. According to JSR 376, the key goal of modularizing the Java SE platform are, please visit JSR website 376, the Java Platform System at https://gcp.org/english/gsr/details with ID 376 to know more details about this GSR. The main goals now are reliable configuration. Modularity provides mechanisms for explicitly declaring dependencies between modules in a manner that's organized both at compile time and execution time. The system can walk through these dependencies to determine the subset of all modules required to support your application. Strong encapsulation. The packages in the module are accessible to other modules only if the module explicitly exports them. Even then, another module cannot use those packages unless it explicitly states that it requires the other module's capabilities. This improves platform security because fewer classes are accessible to potential attackers. You may find that considering modularity help you came up with a cleaner, more logical designs. Scalable Java platform. Previously, the Java platform was a monolith consisting of a massive number of packages, making it challenging to develop, maintain, and evolve. It couldn't be easily subsetted. The platform is now modularized into around 98 modules. This number will change as Java evolves. You can create custom runtimes consisting of only modules you need for your applications or devices you are targeting. For example, if a device does not support GUIs, you could create a runtime that does not include the GUI modules, significantly reducing the runtime size. Greater platform integrity. Before Java 9, it was possible to use many classes in the platform that were not meant for use by an application's classes. With strong encapsulation, these internal APIs are truly encapsulated and hidden from apps using the platform. One downside of this is that it can make migrating your legacy code to Java 9 is problematic. Finally, improved performance. The JVM uses various optimization techniques to improve application performance. JSR 376 indicates that these techniques are more effective when it knows in advance that required types are located only in the specific modules. Now, let's see how GDK folders structure is different from previous releases in terms of modularizing GDK. We know that GDK software folder contains. After installing GDK 8 software, we can see a couple of directories like bin, gre, lib, database, etc. and files like source.zip and javafx-source.zip in Java home folder. However, in GDK the folder structure has been changed a bit differently as shown below. Here GDK 9 does not contain gre. In GDK 9 gre is separated into a separate distribution folder which was redundant and contains the same tools already contained in the bin folder, and this is definitely increase the size. Other files and folders are removed and turned into modules. The GDK software contains folder called gmods. It contains a set of Java 9 modules as shown here. As of today, gmods contains around 98 modules. Gmods folder is available at Java home directory under gmods folder. These are known as GDK modules. So we can navigate to the system folders, and on the left is the folder of GDK 1.8 build 162. Here is the folder structure of GDK 8. We find bin, lib, include. Very interesting, gre, which contain also bin, and they contain all the Java tools which is already contained in the bin folder of the GDK home, which is redundant as we have said. On the right, folder structure of GDK 9, it's totally different from the others. There is no gre, and all the source, javafx-source and source.zip are turned into modules, and we can find all these modules in the gmods folder, which is GDK modules as we have said previously. So far, we have learned about GBMS basics, project history, problems of the previous Java systems, the Jigsaw project goals, and finally comparing the GDK 8 and GDK 9 folder structure and how GDK is changed. That's all about the Java SE 9 module system topics and goals.